Hello everyone, let us look at this problem where we have to use integration to find out area between the curves. It's an application of integration. So the question says for the following, determine the area of the region between the curves by integrating over the y-axis. Two functions are given, x equals to y square and x equals to 9 that have been drawn over here. And we have to find out the area between the curve, that's the shaded region. We have to do it across the y-axis, so we'll take it as dy. First we need to find out the limits from where to where we have to integrate. So if we equate both of these, we'll get this intersection points. We'll equate y square and 9 and solve it, and we got plus and minus 3. So we got that our curve is going from negative 3 in y from positive 3 in y. Now we have to do right function minus the left function. Right function is x equals to 9 and the left function is x equals to y square. Limits has been written over here. After integrating we got 9y minus y cube over 3 and then upper limit and the lower limit. So we have to do upper limit minus the lower limit by substituting the value in for y. After solving this expression we got 36 units square. So that's the area between these curves. Integration gives the area under the curve. So integration is a very useful tool to find the area under the curve as well as between the curves if we can just subtract the functions together between the limits. I hope you understood this. Thank you.